Welcome to Astronomy Daily, your daily dive into the cosmos. I'm Anna.
And I'm Avery. We're so glad you could join us today for a look at the latest and greatest in space and astronomy news.
We've got a packed show for you today, covering everything from how humanity is preparing for potential first contact with alien intelligence to a fascinating new exoplanet system discovered around a red dwarf star.
Plus, we'll tell you about Russia's latest satellite launch aimed at understanding Earth's space weather and the truly wild new helicopter mission concept for Mars.
It's going to be a captivating journey through the universe. So buckle up and let's get started with today's top stories. All right, let's dive into a topic that has captivated humanity for centuries: the possibility of life beyond Earth. Specifically, we're looking at what happens after we discover extraterrestrial intelligence.
Exactly. A fascinating new research paper posted to the archive preprint server from the University of St. Andrews tackles this very question. It outlines how NASA and the global scientific community should prepare for the moment humanity detects signs of alien intelligence.
This isn't just about finding simple microbial life. This is about discovering technological signatures from an alien civilization. The paper, penned by 14 researchers from various institutions, highlights that such a detection would trigger a complex global process, heavily influenced by uncertainty, misinformation, and diverse ideological viewpoints. It would fundamentally reshape our understanding of our place in the universe.
And what's particularly striking is how outdated previous preparation efforts are. Early guidelines from 1989 predate the internet entirely. The researchers, led by Kate Genevieve from the Astral Ecologies Institution, argue that those protocols simply can't account for the rapid global media dissemination we experience today.
Imagine the media firestorm if this news broke now, in an era of viral misinformation and instant global communication. It would be unlike anything humanity has ever experienced.
To address this, the team proposes 6 critical areas where NASA should invest now before any discovery occurs. These range from advancing detection technologies to studying how different cultures might interpret the news of extraterrestrial discovery.
One of the most intriguing aspects is the concept of developing other minds paradigms. This means preparing to recognize intelligence that doesn't necessarily think like us. The paper suggests leveraging techniques from bioacoustics, machine learning, and quantum computing.
They even mention studying whale songs and bird navigation to understand non-human communication patterns. This really challenges us to move beyond Earth-centric assumptions. If aliens communicate through methods we haven't even conceived of, like quantum entanglement, our current detection methods might miss them entirely.
What's surprisingly practical about this research is that much of the preparation work isn't focused on alien technology itself, but on human psychology and interaction. The researchers emphasize integrating humanities and social sciences, recognizing that the biggest challenges might come from how people react to the news rather than from the aliens themselves.
They recommend funding research on the psychological, social, and global dynamics of post-detection scenarios, and even suggest analyzing science fiction stories. They believe these fictional scenarios offer valuable insights into human expectations and fears.
And on a very practical level, the team calls for creating robust international coordination systems before they're needed. They warn that without a proper post-detection SETI hub, NASA risks a gap in the system, likening it to a moon landing without astronaut retrieval.
Just as NASA developed detailed protocols for Apollo missions, including quarantine procedures, they need comprehensive plans for managing a SETI discovery.
While the researchers aren't claiming that discovering extraterrestrial intelligence is imminent, their message is clear. Preparation is essential. With advanced telescopes like the James Webb Telescope already operational and others like the Vera C. Rubin Observatory coming online, a techno-signature discovery could emerge from any realm of astronomy research.
Their message truly boils down to this. The question isn't whether we'll ever detect signs of alien technology, but whether we'll be ready when we do. By investing in research, international cooperation, and communication strategies now, humanity's greatest discovery could become a moment of unity and wonder rather than chaos and confusion. It's a powerful and forward-thinking perspective.
Now, let's shift our gaze from potential alien civilizations to actual new discoveries right here in our cosmic neighborhood, relatively speaking. There's some exciting news out of the exoplanet community.
Absolutely, Anna. Astronomers have just announced the discovery of a fifth rocky planet orbiting the small red dwarf star L9859. And here's the kicker. One of these planets, a super-Earth, is located squarely within the star's optimistic habitable zone.
This system, L9859, isn't new to us. TESS, the Transiting Exoplanet Survey Satellite, initially found 3 planets around it back in 2019, then a fourth in 2021. Now, with this fifth detection, the system is certainly generating renewed interest.
The discovery is detailed in research that's set to appear in the Astronomical Journal, with lead author Charles Cadieux, a researcher at the University of Montreal and Trottier Institute for Research on Exoplanets, at the helm. L9859 itself is an M3V star, a red dwarf, about 34.5 light-years away, and it's quite small, only about zero point 0.3 solar masses.
What's particularly fascinating, beyond just the habitable zone planet, is the overall architecture of the system. It's a tightly packed grouping of terrestrial planets, showing some dramatic compositional differences despite their close proximity. It actually reminds me a bit of the TRAPPIST-1 system, which also has multiple terrestrial planets.
It really does, and the authors point out that multiplanetary systems like this offer a unique opportunity to study how planets form and evolve within the same stellar environment. These new results paint the most complete picture we've ever had of this system, demonstrating the power of combining data from space telescopes like TESS and high-precision ground-based instruments.
Let's talk about some of these individual worlds. The innermost planet, L9859b, is a rare sub-Earth, only about 84% of Earth's mass and half its size, with an Earth-like density. It orbits its star in just over 2 days and might be volcanically active due to tidal heating.
L9859c is also likely volcanic, with about 1.3 Earth radii and 2 Earth masses. Then there's L9859d, which has about 1.6 Earth radii and 1.6 Earth masses, and it might even be a water world, or what's known as a Hycean world.
And the newly detected planet, L9859f, is the one in the optimistic habitable zone. It has a minimum mass of about 2.8 Earth masses, around 1.4 Earth radii, and a 28-day orbit. What's great is that these planets follow near circular orbits, which make them prime targets for atmospheric spectroscopic studies with the James Webb Telescope.
Indeed. Observations already show that the 3 inner transiting planets have increasing water mass fractions with orbital distance, suggesting a diversity of compositions. As Professor René Doyon, a co-author, puts it, this system offers a unique laboratory to answer pressing questions like, what are super-Earths and sub-Neptunes made of? Do planets form differently around small stars? Can rocky planets around red dwarfs retain atmospheres over time?
The question of habitability around M dwarfs like L9859 is a complex one. Because their habitable zones are so close to the star, planets might be tidally locked, meaning one side always faces the star. Plus, M dwarfs are known for powerful flaring, which could strip away atmospheres.
However, M dwarfs are incredibly long-lived stars, burning their fuel very slowly, offering long-term stability for any planets in their habitable zones. The atmospheric characterization of these planets is already underway with JWST, using both transmission and emission spectroscopy. It's truly an exciting time for exoplanet research.
L9859 is definitely joining the select group of nearby compact planetary systems that scientists hope to understand in much greater detail in the coming years. Shifting gears from deep space exoplanets, let's turn our attention back closer to home to Earth's orbit. where Russia has been busy with a significant launch.
That's right, Anna. On Friday, July 25th, a Soyuz 2.1B rocket successfully launched from Site 1S at Vostochny Cosmodrome in Russia. This mission carried two Ionosphera M satellites, numbers 3 and 4, into a sun-synchronous orbit, completing their four-satellite constellation. The first pair, Ionosphera M number 1 and number 2, were launched back in November 2024.
So these aren't just any satellites. What's the main purpose of this Ionosphere M constellation?
These satellites are part of what's called Project Ionozond, a program specifically designed to study Earth's geophysical environment, particularly space weather and its effects on our planet. The data they collect will be crucial for improving space weather forecasting, which has direct impacts on everything from satellite operations to radio communications here on Earth.
And for our listeners who might not be familiar, the ionosphere is a fascinating part of our atmosphere. It's that region roughly 80 to 650 kilometers up where high-energy solar radiation strips electrons from atoms and molecules, creating electrically charged ions. This is where the stunning aurorae originate, and it also significantly affects radio and navigation signals.
Exactly. Each of these ionosphere satellites, weighing around 400 kilograms, is equipped with a suite of 9 instruments, including spectrometers, a shortwave sounder, a magnetometer, and a radio wave sounder. They are designed to operate for 8 years, collecting measurements of the ionosphere at different times of the day, thanks to their carefully planned orbital planes.
It's quite a comprehensive effort. While the ionosphere was first discovered back in 1902 through radio experiments by Guglielmo Marconi, and the Soviet Union flew missions to study it previously, this Ionosphere M constellation really marks Russia's first major dedicated effort to study space weather in many years.
It's a significant step forward for them in understanding and forecasting space weather, which is becoming increasingly vital as our reliance on space-based technology grows. This mission will provide invaluable data to help mitigate the risks posed by solar activity and other space phenomena.
From Earth's ionosphere, let's take a giant leap to Mars, where there is a truly wild new mission concept on the horizon. It's called Skyfall, and it sounds like something straight out of a sci-fi movie.
It really does, Anna. This concept, developed by AeroVironment of Arlington, Virginia, and NASA's Jet Propulsion Laboratory, or JPL, proposes a revolutionary way to explore the red planet. Imagine dropping a hornet's nest of helicopters from high above Mars.
A hornet's nest of helicopters. I love that description. So, what exactly does Skyfall entail, and why is it considered such a game changer?
The core idea is to deploy 6 scout helicopters from an entry capsule during its fiery plunge through the Martian atmosphere. The ingenious part is that this Skyfall maneuver would eliminate the need for a traditional landing platform, which has historically been one of the most expensive, complex, and risky elements of any Mars mission. It's a real cost-cutting concept.
That's a massive shift from previous missions. And once these 6 helicopters are deployed, they don't just sit there, do they?
Not at all. Each helicopter would operate independently, essentially fanning out to explore various sites. Their primary duties include transmitting high-resolution surface images back to Earth and, crucially, collecting radar data about what lies beneath the red planet's rocky surface. This subsurface information is absolutely key for safely landing future human crews, especially at locations identified as holding water, ice, and other vital resources.
So it's not just about scientific exploration, it's directly paving the way for human missions to Mars. This concept clearly builds on the incredible success of the Ingenuity Mars helicopter, which, for those who remember, achieved the first powered flight on another world back in 2021 and completed 72 flights in just under 3 years.
Exactly. William Pomerantz, head of space ventures at AeroVironment, has highlighted that with 6 helicopters, Skyfall offers a low-cost solution that significantly multiplies the range we can cover, the data we can collect, and the scientific research we can conduct. He states it will make humanity's first footprints on Mars meaningfully closer.
And it sounds like this isn't just a distant dream. AeroVironment has already begun internal investments and coordination with NASA's JPL to facilitate a potential launch as early as 2028. It's truly exciting to see such innovative thinking pushing the boundaries of what's possible in space exploration. And that brings us to the end of another fascinating episode of Astronomy Daily. What a packed show it's been.
It certainly has, Anna. We've journeyed from the profound questions of preparing for extraterrestrial contact with the SETI post-detection hub's new guidelines to the exciting discovery of 5 new rocky planets around the L9859 system, including a super-Earth and the habitable zone.
We then shifted our focus to Earth, discussing Russia's successful launch of the Ionosphere M satellites, which will contribute vital data to our understanding of space weather and Earth's ionosphere.
And finally, we ended our tour with the truly innovative Skyfall concept, a potential Mars mission that envisions deploying a fleet of scout helicopters to map the red planet and pave the way for human exploration.
It's been a stellar day for space and astronomy news, and we hope you've enjoyed exploring these stories with us.
Thank you so much for tuning in to Astronomy Daily. We love sharing these cosmic updates with you. And before I go, a quick plug. Please visit our website for more space and astronomy news, plus a complete catalog of all our back episodes. But I warn you, there's a lot of content there. Okay, time to go.
Until next time, keep looking up, keep asking questions, and always stay curious about the cosmos.
Goodbye for now.